Let's get into the fourth question. Now, what's this question? Given that HCF of 306 and 657 is equal to 9, find its LCM. That means the HCF of two numbers, here almost bigger number. What are they? 3-digit numbers. 306 is one number, another number is 657. The HCF of these two numbers are given as 9. We have to find the LCM. How can you find this one? Already we have studied about the fundamental theorem of arithmetic. When I explained that one, I told you that there is a theorem. There is a formula which we have to apply. If you're taking any two numbers, the product of that two numbers will be exactly equal to the product of their HCF and LCM. That's what we are going to check here. So we will write, we have what we have, HCF of 306 and 657 is equal to 9. That is given. So given statement every time you have to copy. Next step, we have what we have, we know, or we can write we know. What we know? HCF into LCM is equal to product of the numbers. Now instead of HCF, how much is HCF? It's given 9. We will write 9 into LCM is unknown. We have to find that one. So we will write LCM itself. So 9 into LCM is equal to, what are the numbers? The numbers are 306 into 657. Now we have to find the LCM, right? So keep the LCM on the left hand side and take this 9 and throw that to the right hand side. When you are taking a number from one side to another side, forget not, the sign will change. So in between the numbers which are there on the left hand side, if it is an addition or subtraction, when you're taking that number and bringing to the other side, definitely the sign changes. Whereas if it is the product of numbers which is in one side, that means if it may be in the LHS or maybe in the RHS also, that's why it's called one side. If it is in the form of product of two numbers, definitely when you're taking that number and bringing that to the other side, it will become divided. Clear? It will become it will come on the numerator. Here it was in the numerator part, and when it is coming to the next side, it will become into the denominator part. It will become divided by. Okay, so here 9, when we are throwing that 9 to the RHS, when you're taking this 9 to the RHS, what happens? LCM is equal to 306 into 657 divided by 9. 9 and 306, both of them, they comes in the table of 9. You can cancel it with the table of 9. Cancelling it, you will get 34. So the answer is 34 into 657. 34 into 657. That's equal to, how much is the answer? 22,338. So we can say therefore the LCM is equal to 22,338. So by using this theorem, you can simplify. Even if the question is given to find HCF, you can use the same method. Even in some questions they may be given like this, that the HCF and LCM will be given and one number will be given and you have to find the another number. At the same time, you have to use the same equation itself. Put the equation, frame that equation. After framing the equation, what all things are given inside the question, substitute them. And what is the odd one? What is the thing which is not given? That will be the odd one, and from that one you will have to find this one. So this is the way how to do that one. Hope you understood. Next question. Check whether 6 raised to n can end with a digit 0 for any natural number n. Okay, that means 6 raised to the power n, n can be any natural number, means it can be 6 square or it can be 6 cube, it can be 6 raised to 4 or it can be 6 raised to 99, it can be 6 raised to 1000, it doesn't matter whatever the power is. Our question is, will that number, whatever the power it is, it doesn't matter, but will it have or will that number end with 0? That's it. So see here, this is the importance of the fundamental theorem of arithmetic. Here we are going to apply this one actually. See how we are going to apply. Forget not, I already told you that when I was explaining the fundamental theorem of arithmetic, I told you that any composite number can be expressed as the product of primes in a unique way, right? That point was so important. Unique way means in a single way, means there is only one and only one way to represent it as the product of primes. It may be in any order, but it can be written only in one form. Means only those numbers, means whatever numbers you are factorizing and you are getting, only those numbers will be there when you are writing the product. That's the meaning of that one. So we are going to apply that same theorem here. That's why I told that theorem is so important. See here, our question is whether this number, it can be any number. See here it is given 6, it can be 9, it can be 20, it can be 30, whatever it is, this is the method. How we can check it? Understand this technique very, very perfect. Understand the way how I am going to get the solution. See here, 6 raised to the power of n is given, right? Let us factorize this 6. While factorizing this 6, what you will get? 2 into 3, right? Because 6 is a composite number. So 2 into 3 is the factor of 6. It is the prime factors of 6. So we can say it is as expressing it in the product of primes, we can express 6 as 2 multiplied by 3. That means 6 has only the factors 2 and 3. Now, what was our question? Will this number end with 0? If any number should end with 0, this is important one. If any number should end with 0, definitely it should be the factor of 5. Means it should come in the table of 5. It should come in the multiplication table of 5. Then only the last number will become 0. That means how much factors you are writing, one of the factors should be 5. Did you got the idea? One among the factors should be 5 itself. Now tell me, did you got 5 when you factorized 6? Did you got it? No. Then what did you got? You got only 2 and 3. So we will say that as 5 is not in the factor of 2 and means while factorizing 6, 5 doesn't belong to this one, right? Inside this one 5 will not come. So that's why we can say as 5 is not a factor of 6, definitely this number is not going to end with the 0 for any natural number n. So how will you write the answer? It's just a 1 mark question actually. You will have to explain that one. There is nothing to prove or nothing to solve actually. You have to explain it. What will be the explanation? It's like this itself. In 6 raised to m, while factorizing 6, we understand that 6 can be expressed as the product of primes. That means 6 is equal to 2 into 3. Full stop. Then we will say if any number should end with 0, then definitely that number should be a factor of 5. While checking, we can understand that here 6 is not having 5 as one of its factor. Therefore, this number will never end with 0 for any natural number n. Means whatever power you are giving to that n, it doesn't matter, it's not gonna end with 0. Like that you can conclude. Clear? Question number 6. Explain why 7 into 11 into 13, 7 into 11 into 13 plus 13 and another number 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite. Means two numbers are given. We have to explain why they are composite. This is also a 1 mark question. We just need explanation. They just need explanation, right? There's nothing much. You just have to explain that one. See here, how will you explain this one? How are you going to explain this one? You have to explain that these are composite numbers. You may be thinking that you have to multiply all these numbers, then finally you have to add 13 with that number, you will get a big number. Then you will say that this whole number, it's a composite number. Means then you have to factorize that one, right? It's not at all like that. There is no need of like, forget not. What is a composite number? A composite number is a number which has more than one factors, Let us check it out. In this first question, see the first one, 7 into 11 into 13 plus 13. 7 into 11 into 13 plus 13. So in these, there are two terms, right? How can you understand there are two terms? Because there is only one addition sign. So in front of the addition, 7 into 11 into 13, that is one term. 13, that is the second term. So in these two terms, 13 is common, right? 13 is common. So bring out that 13. Take the 13 outside. So if you're bringing out that 13, how can you write? 7 into 11 into 13 plus 13 is equal to 13 multiplied by the rest of them you have to write inside brackets, within brackets. 13 into 7 into 11 plus 1. That means 13 into, what is 7 into 11? It is 77. 77 plus 1 is 78. That means 13 into 78. Now tell me, how many factors does that number have? Already 13 is one of its factor. Another one, 77, right? 78, right? 78 is one of its factor. 13 is also another factor. So that means it's a composite number. It's clear. What about the next question? See there, 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. In these two terms, 5 is common. Take it out. When you're bringing this out, when you're bringing this 5 out, what will happen? Within brackets, 5 into, offside, after that one, 5 into, then bring it. You already took 5 outside. Now there is no 5 inside this one, right? So 7 into, 6 into, 4 into, 3 into, 2 into 1. Plus this one already you took it outside, this 5 already you took it outside, so there will be only 1 left there within brackets. Whatever answer you are getting inside this bracket, it doesn't matter. It's already having a factor as 5. 5 is one of its factor, and this whole number which you are going to get after multiplying and adding all these numbers within this bracket, you will get another number, another natural number. So already we can say there are two factors. There is no need to find the answer which is within the bracket. Actually, simply we can write like this: 5 is one of its factor and it is multiplied to another number. So definitely it is having more than one factors. So we can say that number is also composite. That means without dividing or without multiplying, without factorizing, simply we can assume, we can tell it because it is having more than one factors. Clear? Question number 7. There is a circular path around a sports field. Just imagine that sports field in your mind, and there is a circular path. You know that children, those who are running or for morning walks and etc., those who are going around, you have been seen plenty of people walking in that circular path, right? Just imagine that in your mind. Okay, you have to visualize that in your mind itself. When you are watching a question, when you're reading a question, you have to imagine that in your mind. Then only you will get into this question. Then only you can understand this question actually. So imagine here, what is the question? There is a circular path around a sports field. Keep that in your mind. Sonia takes 18 minutes to drive one round around this field. So there is a girl, her name is Sonia. If she want to take one round around this path, how much time does she need? She needs 18 minutes to complete one single round. At the same time, see the question, Ravi takes 12 minutes to complete the same round. That means if Sonia is running, she will take 18 minutes. And if Ravi is running, he is much more faster. He will reach in 12 minutes, he can complete one round. He is much more stronger, that's it mean, right? So he will complete that round in 12 minutes for the same. Now, suppose they both starts at the same point and at the same time. Suppose, just imagine that both of them are standing together and they are about to take a leap, and they are standing together and they are going to run. They are standing at the same position and they are going to start exactly at the same time. That's what the question means. Clear? Now, and they are going in the same direction also. They are going in the same direction. They are not going in the opposite direction. They are standing in a position, and at the same position they are standing. At the same time, they are going to start their run in the same direction. Both of them are going in the same direction. Keep this in your mind, okay? So Sonia, she will take 18 minutes to cover one round, whereas Ravi will take only 12 minutes. This much must be there inside your mind. Okay. Now, after how many minutes will they meet again at the starting point? Means anyhow, you know, Sonia will be very later. She will be running and coming a little bit later than Ravi, because Ravi is already faster than her. He will take in 12 minutes. He will reach this point, and just imagine that he's not stopping. Okay, he's not stopping. They are continuing their run. They are continuing to run, and just imagine like this. Ravi ran. He came here to the. This is the starting point. Ravi ran all the way. This is the starting point. Ravi ran all the way. He came to the same starting point, and at the same time, she is also running, and she will be coming here. But at the time, what will happen? Ravi will be already went ahead, right? Because he is already faster. So, but there are chances that they will meet again. It may be after 20 rounds. It may be after 16 rounds. It doesn't matter. It may be after 40 rounds. But anyhow, somewhere and somehow they are going to meet again. And our question is to find the next time. After how many minutes they are going to meet again at the same time. It doesn't mean that, don't think that they will meet again means the speed of Ravi will become less, or the speed of Sonia will become fast, and they are going to they will be coming in the same time. It's not like that. She may be continuing the round again and again like that, but she will be taking 18 minutes itself. She will be taking 18 minutes itself, and Ravi will be going in 12 minutes itself. He will be completing each round. But the main thing is that after pretty good of rounds, they are going to meet again at a particular time. We are going to find that time. That means we have to find the least time when they are going to meet. Did you notice the word least time? That means you have to find the LCM of this number. So finding the LCM of these numbers will be the solution. So let us find the LCM. Which method should we adopt to find this one? Exactly the prime factorization method which I have studied right now. Come on. So 18 is equal to, how can you express 18? 18 is equal to 2 into 3 square. 2 into 3 square, right? What about 12? 12 is equal to 2 square into 3, right? So both of them you have expressed as the product of primes. And now, how will you select the HCF and LCM? Here, there is no need of HCF. We want only the LCM. How to select the LCM? It is the product of all the primes with the highest powers. You have to multiply all the prime numbers included in both of these, but you have to take the highest power. Let us see here, which are the prime numbers included when you are factorizing 18 and 12? 2 and 3 are the prime numbers, right? One is 2, another one is 3. So take the bigger power. Anyhow, 2 into 3 will come there. And now let us check out the powers also. What about the powers? In first one, you can see 2 is of the basic power, 2 raised to 1. But when you are taking 12, you know 2 square is there. So which one is bigger? 2 square is bigger. So we will choose that one. So 2 square into, next number is 3. Which is the biggest power of 3 here? It is 3 square, right? So 2 square into 3 square. That means that is equal to 4 into 9. That is 36 minutes. That means after 36 minutes, Ravi and Sonia, they are going to meet at the same point, means at the same starting point. They will come there. It doesn't mean that, see, even though after 36 minutes they came at the same point, means never think that they were running a same lap. That means Sonia also completed 12 rounds and Ravi also completed 12. It may not be like that. Anyhow, we know that Ravi is more faster than Sonia. So definitely the total rounds covered by Ravi will be much more than of Sonia. But they will be meeting again at the same point exactly after 36 minutes. You have to understand at least what you are doing. That's why I explained this much. Hope you understood this video. That's all from this exercise. We will go to the next topic and get on to the next exercise in our next video. Thanks for watching.